Same. It's building decentralized Web3 infrastructure is hard when it's actually decentralized. But your speaker will be Pierre. So give him a round of applause as he makes his way up to the stage. Sorry.
Hi there, everybody. I'm Pierre. I'm a contributor at Threshold. If you haven't really heard that name before, you may have heard us as maybe new Cipher and or Keep. So right around, maybe around January 2022, New Cipher and Keep were working on were separate projects working on different threshold cryptography protocols. So if you want to think about threshold cryptography in general, it's this concept of splitting cryptographic operations across independent entities as a way of securing the operation. So in other words, you're not relying on a single entity to perform some operation. You're relying on some group of them to collectively perform that operation. But the interesting part is that you don't need all of them. You only need a threshold of them, so some minimum number. So you can think of it as 10 out of 20 or 11 out of 20 to complete some operation. And you might think, well, why exactly do I need this? And so it's increased security. It also solves an availability problem. So you think of nodes that maybe some entity goes down, you still have some buffer that allows the operation to continue. And so New Cipher and Keep, on their own, were working on these protocols. In Keep's case, they were working on TBTC, which is this cross-chain bridge, cross-chain Bitcoin bridge. So lots of people out there holding Bitcoin, but want to participate in DeFi perhaps, and so you want to use your Bitcoin on the Ethereum blockchain. And so Keep worked on this ability to have a distributed wallet. So you have a bunch of entities controlling a wallet on your behalf. Because typically, centralized custodians, you have to trust them to hold on to your actual Bitcoin, and trust that they won't run away with it. And so in Keep's case, that was less of an issue. It's trust minimized because you have these number of nodes, and collectively they have to come together to do anything. And in New Cipher's case, we were working on this thing called proxy re-encryption, which is this end-to-end encrypted data sharing protocol. So you think of, you want to share data with some other person, you want to grant access to them. How do you do that without the thing granting access gaining control to your private material? And so New Cipher was working on that, and we had a network of nodes, so did Keep. And so as a result, we thought, hey, we're kind of working together working on the same kind of protocols. Why not work together and put something together that everyone can use? And that's how Threshold Network was born. And so fundamentally, Threshold Network is just a collection of interfaces and runtimes that perform threshold cryptographic operations. You just think of it as that. And so that happened in January of 2022. We've been going strong since. Since then, proxy re-encryption has relaunched on the Threshold Network, so has TBTC. TBTC has actually been improved, some of the scaling issues that they had before. And one of the big things I wanted to talk about today is why, when projects talk about being decentralized, why is that difficult? And when projects talk about, down the road we're going to become decentralized, is that feasible? And why that can be a tricky process. So just to start things off, threshold access control is what we sort of talk about when it comes to proxy re-encryption, and we're adding this thing called conditions-based decryption. And what that means is you can encrypt data for anyone and add conditions to that data where the data could only be decrypted if that person satisfies some condition. You can think of that condition as, do you own an NFT? So think of you being maybe a content creator, and you say, hey, I want to share data with only people who buy this NFT. And if people buy this NFT, the data can be decrypted for them using the threshold network. So basically, threshold access control is this collection of CBD and PRE that allows you to sort of maintain access controls. So a example is master file. So this is a project that's building upon threshold access control, and they are that content creator maintaining control over their data and how they share it with customers or people who just want to consume that content. Masterfile has been working very hard on this decentralized digital rights management. So you as a content creator, how do I want to share my data? Maybe I sell my data and I say it can't be resold, for instance. How can you do that in a decentralized way? And so Masterfile has been using our protocol to add this functionality to their system and provide that functionality to content creators. And so how this conditions-based decryption kind of works is that it's built on top of something called distributed key generation. And all that is, that you might think that's a lot of technical mumbo-jumbo. All that is it's a collection of nodes getting together to generate an encrypting key. So each node generates a piece of cryptographic material that contributes to this encrypting key. And then from then on, only, let's say you take, it's 20 nodes, let's say, come together to create this key. You can encrypt data with that key and only require some threshold of them, say 11 of 20 of them, to decrypt data, right? And so the important thing there is that no individual entity, in this case nodes on a network, can decrypt the data by themselves. They need a threshold of them. In this case, in the example, 11 of 20. So you as a consumer of data, you get the data encrypted. You go to the network and say, hey, I think I satisfy this condition. I need you to decrypt this for me. And so all that happens is that you talk to 11 out of 20 nodes. They will each decrypt part of it, or this decryption fragment. You collect 11 of them, and then you can decrypt the data, no problem. And the nodes will check to make sure that you satisfy some condition. So what that looks like. So the nodes generate a key. Some data owner, that could be a content creator, for instance, takes their data, attaches some conditions to it. Those conditions can be anything on-chain related. So it could be a time condition, like you can only access this data after a certain block time. Or you can only access this data if you have a certain balance of ETH, for instance, in your wallet. And so those conditions get attached, the data gets encrypted and stored somewhere. So on our network, it's only access control. It's not storing of the data. You can store your data wherever you want, whether that's IPFS, Arweave, etc. And then next up, now the person that wants to consume this data gets it from storage, says, okay, I have this encrypted data with some conditions in it. Let's say in this case, it is that you as the owner has to own some amount of ETH, right? So the condition says, you know, the person trying to access the data, their wallet has to have a certain amount of ETH in it. Now you could do something funny, right? You say, well, okay, I just input whatever wallet I want, right? If I just put in Vitalik's wallet, and then the condition will pass. But in this case, you actually have to sign a message with that wallet to prove that you own it. And that's just a regular, I don't know if you've heard EIP 712 signature. So you send all that up to the nodes. The nodes say, okay, this is the condition. This person has proved that they own this wallet by having a valid signature. I can verify that signature on chain, no problem. And as a result, each node will say, okay, you satisfy the condition. I will decrypt only part of it, only the part that I can. And you will collect all of these fragments. And then together, once you have the fragments, you can decrypt the data is decrypted for you, no problem. And so back to the original reason for the talk, which is, why is that difficult? So in that system, there's a lot of moving parts. And when projects talk about being decentralized, you really have to think about the different components and the different parts of the protocol that lend to them actually being decentralized. So an example would be nodes. So you have nodes on a network. How do you make sure those nodes are independent? Because the one thing about threshold cryptography is, again, if you get a threshold of them to come together and do something, they can do it. Them individually can't. And so collusion is your enemy. And so you have to make sure that nodes are independent, right? How do you make sure that one entity doesn't control 20 nodes on your network and therefore can control an entire sort of access control key, right? So independence is a big thing. On top of that, how do you incentivize people to run nodes for your protocol, right? That's where crypto economic protocols come into play, staking, fees. Another thing about fees is that nodes have to be sustainable. So if they are running a node on your network, one incentive for sure is for it to be economically sustainable. If they're losing money running a node, why would they run a node, right? So there's staking rewards, there's staking fees that are generated from the network. Some other things to think about are node discovery. So you have a bunch of nodes. How do they talk to each other? How do they interact with the protocol? How do they start up, right? Who do they connect to start? Can they connect to any node? Do they have to connect to a centralized node? Because that's very different, right? That centralized node goes down, no node can start up. And things like a distributed key generation protocol. A lot of projects may be able to generate, anybody can generate an encrypting key. That's very easy. It's public key cryptography. But can you generate in a decentralized fashion where no one knows the private key at all, right? You can generate a public key, but nobody should know the entire collected private key. Instead, if you saw in the previous diagram, those things are split apart, right? So each node only has a piece of it, and the private key is never constituted anywhere. And so these are all of the different issues that come up, and that's before you even talk about having a threshold decryption scheme, or a threshold scheme for that matter. And so the scheme itself is very easy, but all of the other parts of the stack is where the difficulty lies. There we go. There we go. So when you are working with protocols that provide Web3 infrastructure like we do, right? We provide threshold cryptography. Some of the things you got to ask are, how many nodes are in the network? Obviously, you don't want a small number because collusion is a lot easier if you have a small number of nodes. Independence, of course, incentivization. How do you prevent collusion, not only as part of the protocol, but as part of, do you slash if there are misbehaving nodes? And somehow you're able to detect that, hey, these nodes got together in a malicious way to circumvent the protocol. A big thing, particularly when it comes to rewards, tend to be the token supply. So how are rewards distributed, right? Is that a manual process? Is that based on contracts? Another thing is governance. So with Threshold is a DAO. It's community owned. It's run by a DAO. There's no single entity that controls anything. Our contracts are owned by the DAO. And so as a result, if you are run by a DAO, or if you are run by a commercial entity rather, what can you do? Even as a DAO, what can you do, right? So let's say the DAO owns the contracts. Do you have things like, what's the threshold for votes to go through, governance votes? Is there a time lock that allows for a certain amount of time between vote being passed and inaction of that vote, right? So that if there's something malicious going on, people can detect it. is there a way to prevent that vote if that's necessary, if it's something that, for whatever reason, passed through governance but is actually malicious to the network? And what are sort of the governance procedures for that? And in terms of software, it's more so, I mean, we've all talked, I'm sure we're all used to open source, but not all projects have open source software. Is the code open sourced? Can anyone see it? Is the client code open source? Is the operator code open sourced? How is it downloaded? Is it a closed system? And more so, how is development done? How's the research and investigation and design done? Is it done in public? Is it done in private, etc.? So these are a lot of things to ask because they matter when it comes to actual decentralization. So an example would be for us on the Threshold network, when we launch our conditions-based decryption CBD project, what we're not compromising on is the trust that's built into the system. So it's trust minimized, right? This is a distributed network. No one entity is trusted. And so as a result, right now, our goal is to launch with a permissionless group of nodes. So that means any node on the network can be used. But instead, what we do is we say, as a rollout, sort of an alpha version, it's still decentralized, but what's different is we might limit the size of the group just to make sure that designs are working as we expect. Things like minimum stakes, for instance, things like what group are we sampling from, right? So it's still decentralized, but maybe we say, nodes have to specifically opt into this application, and then we will sample them. And so you end up in a system where initially we're going to start off with smaller groups, but as things progress, we will increase features like increase the size of the cohort, maybe allow for higher minimum stakes, uptime requirements, actually be able to verify the DKG on chain. Right now it can be locally verified. And so over time, what's going on is the decentralization part of it is always there, but what's changing is the features moving forward, right? Maybe another thing to think about is some of these nodes, there's such a thing as node degradation, right? Nodes decide to go down. It's a threshold, so you do have some buffer. But what you can do is you can say, hey, what if I can recreate this same cohort using the same key with a different group of nodes in a secure fashion? So that's something that we're working on. It's not going to be available initially, but over time it will be. And so just to sum things up a little bit, planning to decentralize is not the same as decentralization. And I'm not saying that there is malicious intent in saying that you're planning to decentralize. I'm just saying that you want to ask the right questions in that what's the actual plan to decentralize, and what are some of the hurdles that you're going to hit going from any kind of centralized project to a actually decentralized project. Because it's very different when you control the nodes. So think of Amazon KMS or something, right? Imagine them trying to go decentralized in one step. It's just not feasible. The other thing is anybody who talks about doing centralized threshold decryption, it is basically equivalent to Web 2. Because if they control the nodes, again, collusion is your enemy, and it's very easy to collude with yourself. And then in our case, our goal is to run about 50 to 100 nodes on an initial launch, and that we hope to have that this month. We do have a test net where we run our own nodes, and that is definitely not decentralized, but it's a test net. We don't expect people to run production code on there. That's just for people to test out our system. But that's purely for a test net, and it acts the same way. It's just that we control the nodes, truthfully. That's available now for hacking on. In fact, some members of our team are working on a hackathon project. Justin Miles is launching his album using conditions-based decryption, where basically it's like a revealer case where you pay, people can contribute to the album, and you pay some amount of money, and when it hits a certain amount of money, then the album gets decrypted, and now anybody can listen to it. So it's pretty cool. And so if you want to reach out to us, we're the Threshold Network. You can reach out to us on Discord and on Twitter as well. Follow us on Twitter. And happy to take any questions that people may have. Sure.
I saw before that you show an actual project that it's using polygon, threshold, and so on.
Yep. Master file. Yep.
Yeah. My question is very simple. My question is very simple. What is exactly threshold? Because it seems like an IPFS, but it's also very similar to a blockchain. But I don't know.
That's a good question.
It's really a decentralized storage, or what is exactly?
That's a good question. So Threshold is just a network of nodes providing threshold cryptography. In this case, it's providing access control. So you can think of it as an access control layer, right? So the data gets stored somewhere separate, doesn't matter where it is. Truthfully, it could be even on S3 if you wanted. But what happens is when somebody wants to actually access the data, then they hit the network. The network then checks conditions in this case and says, hey, you are allowed to have, I'm allowed to decrypt the data for you, and I will decrypt it in a threshold cryptography, in a threshold manner. Does that make sense? Yeah.
Checking the conditions, what exactly, how does it work? The nodes can check the chain that they're on, or anything on the internet. Do they act as oracles, or?
Great question. So the conditions are based on blockchains. So it can be an RPC condition. So if you're checking someone's balance, it could be an arbitrary contract. Now our goal is to be multi-chain, right? So any chain, but initially we'll be supporting ETH and Polygon. And the only limitation the only limitation is that because the nodes are decentralized, each node has to have a connection to the relevant chain. And so we kind of have to make sure that nodes are able to connect to any chain. And that's sort of a interesting dilemma. Like, do you have them just provide Infura endpoints, for instance, or do they just use like their Infura ID and then you just derive the chain? But initially it would be ETH and Polygon. But it could be any on-chain condition. So that could be a contract call, obviously a read contract call, or an RPC call. Yeah.
As an add-on,
Sure.
so I'm looking into how to get signers. It's like Particle is doing something like that. So to get a signer that is doing threshold signing, but then I want to check, does someone have a Google account? Does someone have a GitHub account? So is that possible with a threshold as well?
So in terms of conditions, checking that somebody has like a Google account would be like a kind of a Web 2 sort of setup.
So besides checking some conditions on-chain, also checking conditions off-chain. Is it purely on-chain?
At the moment, it's purely on-chain. Just because, when you go off-chain, it becomes a question of oracles and who are you trusting therefore, right? Whereas on-chain, it's very easy to check, right? And you don't have to trust anybody. It's Byzantine fault tolerant. Sure. Okay, maybe one more, or? All right.
No.
All right, thank you very much.